Right, as we try to unravel this very interesting story, hoax or whatever it is, cover, here's a pretty good question for you, Richard. It says, Art and Richard, I'm having a terrible problem understanding the nature of the EQ Pegasus signal. Is it just a carrier wave, or is it ones and zeros? Is it modulated? Is the signal a code? Does it say anything, or is it just a noise pulse? Help, I'm going nuts. Bill in San Diego.
Okay, according to the engineering I looked at, it appears to be just a carrier wave. In other words, just a signal. There's no information on it. Now, there's a body of literature about how you deal with a thing like this. And for many years, in this literature, which is now 30 years old since Morrison and Cocconi's first paper in Nature back in 1959, and then Frank Drake's project Ozma at Green Bank at the radio telescope, an 85-foot dish, where in 1961, I believe, they listened to a few stars for signals.
Yes.
The idea would be that if somebody out there was trying to get our attention, you broadcast a very simple but powerful signal at one frequency.
Right.
And then you basically send the information at another frequency.
Yeah, actually, Seth, for example, confirmed that. I mean, he said that is the premise under which we operate, that there would be a central, very strong thump-thump kind of signal.
A beacon frequency it was called.
That's right.
And it would be around the interstellar song of hydrogen. The universe is mostly hydrogen. Hydrogen, when left to its own devices in interstellar space, undergoes a transition called an electron flip, which generates a little pulse of energy at 21 centimeters wavelength, or 1440 megahertz, 1,420 million cycles per second.
Right.
If it's at rest. Now, if it's moving, it's Doppler shifted. And you have clouds of hydrogen, and they're going up in frequency, and other clouds going down in frequency, and you have hydrogen being swirled around, forming stars and all that. Well, on this background sea of natural radio emission, noise, the thought has been that any ETs out there, or someday ourselves if we ever get up the gumption to transmit and not just listen, we would send, or they would send, a message, a beacon, a call on this common kind of universal frequency.
And so you would expect to find it about where it has been found.
At 1420, but the signal we're seeing is not at 1420, it's up at 1450 and change.
Yeah, but that's so close.
It's close, which is what gave me the idea, wait a minute, suppose it's a blue-shifted, Doppler-shifted up frequency because the source is approaching us. By using that premise on Friday night on the air in real time, I calculated a rough amount by which that signal had to be moving toward us in a ship, in a probe, in a spacecraft of some kind, if the rest frequency would be 1420. And that turned out to be about 2% the speed of light, or about 4,000 miles per second. And I then said, it has to slow down. If it's going to get here, if it's going to stop and visit, it can't just sail through like Rama, which was the ship in one of Arthur Clarke's novels, Rendezvous with Rama. It has to slow down. If it slows down, the frequency will have to fall, indicating that velocity is being bled off somehow, and that should be reflected in radio receivers tuning lower and lower to see the same signal. And lo and behold, Art, that's exactly what we've been seeing.
Indeed. All right, here's a fax from Matt, and I think this tracks with what you're saying. You tell me. Art, I've been following the EQ Pegasus signal coverage over the last week or so, and I have a couple of comments about the recent Australian verification. One, the Australian site did pick up a signal very close in frequency and direction to the door signal. The Aussie signal was a little off direction, though, not exactly at EQ Pegasus. This seems to indicate that the signal is coming from somewhere between here and EQ Pegasus. It seems to me that someone very good in geometry ought to be able to use triangulation to pinpoint the exact location of the transmission's origin based on the exact antenna angles where they picked up the signals and the positions of the antennas. Two, the Aussie signal had a slightly lower frequency, meaning to me that the transmitter is decelerating towards us. Sign Matt.
Matt, go to the head of the class. You got it. Now, see, what I find so astonishing, Art, is that here's a guy, I mean, we don't know his background, his education, whatever, he's figured it out. The guys in Australia who are PhDs, tenured, you know, they're basically on the government paycheck to do this stuff.
Stay good and close to the phone for me.
They couldn't figure it out? They couldn't understand that if you're dealing with a beacon on a spacecraft and it's moving, it will move in the sky and it will change in frequency.
Mm-hmm.
You know, Matt, whose credentials we don't know, can think better than the professionals at one of the world's biggest radio telescope facilities. Come on, boys and girls, which one are you going to believe? I think we're being conned by the pros, because if it is real, imagine what we're in shock for, in store for. Project Samson, the pillars being pulled down, the paradigm changes, E.T. finally shows up. I mean, can you imagine? This is a movie unplaying itself in real time, with all of the extraneous noise and hoopla and breastfeeding, and some people it's not invented here, and so they're not going to sign on until it's overwhelming. This is soap opera, real-life scientific soap opera. Now, what we're going to do is put together our receiver and our antennas, and we're going to start to listen probably in the next couple of days. I think our folks will be ready.
I'm ready. I'm almost there myself, Richard. I've got a 3.8 meter dish, not big, but it's a big signal, and I have it's on a equatorial mount. Unfortunately, I don't have azimuth elevation, but I'm
now
getting.
You're in a good position because you're in that valley surrounded by mountains.
And I've got a receiver that'll cover the frequency in question.
Oh, wonderful!
I'm so close, Richard. All I need is the right LNA out there, and I'm getting close. If this keeps going, I'm going to go out there and mount an LNA.
All right. What we're going to do is publish on the web the next day or so, maybe tonight, if my guys can get it ready, the graph showing the plot of decreasing frequency with time. Because if you're listening at 1453, you're not going to hear it. Now, what I find fascinating is that the SETI League folks and Seth Sostek's people, and even the folks in Australia, they're listening at EQ Peg as if it can only be there. They have a narrowed beam for their telescope, meaning it's like looking through a high-powered telescope where you only see a small part of the sky.
Sure.
They don't see it because, A, they're physically not looking now in the right direction. It's moved a bit. And they don't hear it because they're listening at the wrong frequency, like trying to listen to you on KOB here in Albuquerque by listening to TOP in Washington.
Wouldn't work.
Wouldn't work.
All right, listen, we got a lot of people on the...
101.
I've got you.